in. Work inside the boxes, various symbols, and fraction bars to figure the answer you need to work with on the outside. Boxes are packed from the inside out. So what I'm calling boxes are grouping symbols. Looking over here, grouping symbols override everything else. That's why they're invented. It means this is important, this is being packaged together as a unit in a box, and you have to figure out what's in the box first before you can go on. You can't just pick and choose out of the box. You got to get the answer for the box and then do something. And so you've got different grouping symbols, and I, again, will not get to all of them here. I'm just introducing. There's no real difference in meaning except for these absolute value, and I'll show some examples of those later. Otherwise, they just group. Okay, let's look at the first example here. We're looking at this line. That's not a -3. There, that line. 3 times 5 plus 6 in the box. So here's one little thing. These are like transparent boxes. And can you imagine a kid at Christmas? And all the presents under the tree are wrapped in transparent boxes. He's looking at writing, oh, the temptation to get right in there and pick out what he wants and see what's in the box and then take just what he wants. Well, that same temptation happens here. And, well, I see the 3 parentheses 5. Let's just make that 15. The box. It's a whole package. It's 3 times the box. It's not just 3 times the 5. It's 3 times the 5 plus 6. So I have to figure that out first, which is 11. Now I can take 3 times the total value, the answer value of the box, and then work with it. So now I've got 3 times 11 minus 7 times 5. I've got multiplying. There were no functions. Fine. Do it in order. Sometimes you'll skip it. I did in up here first. Now I can do any multiplying that I see. 3 times 11 is 33. 7 times 5 is 35. So 33 minus 35 for my last step, combining, as usual, -2. I'm done. So I go in order, and I stay at that step until it is done. Then I go from working inside boxes. I then go to any functions I see. Then I go to multiply and divide. And then finally, my last step will be combine like terms. Next problem, we're looking at this line. 4 times the box, and the box is 6 plus 2 times 5. Oh, so sometimes now I've got to use order of operations inside the box to come back out and continue using order of operations. So inside, I have to do the 2 times 5 before I can combine it with the 6. So down here, I'm inside, and there was no inside the inside. There were no functions inside, but there was multiplying inside, so I get 10. 6 plus 10 now on the inside gives me 16. Now I can come outside. I'm all done inside. I can come outside and multiply the answer value of the box, which is 16. All of this boiled down to just 16. Now I can come outside and multiply and get 64. Now let's make things just a touch more complicated. Let's add some functions so that we can see everything in here in FUN MUD COLT. The colt's having fun in the mud, if you can put that picture in your mind. In FUN MUD COLT. Let's start with our first step of our first problem. and I see parentheses, I see a box, I'm going to work inside there first. And now that I'm inside, I'm going to follow in FUN MUD COLT there. It's just combining, so 3 times 11, and I'm down here. I copy everything down. I am now done inside, and so now I can work outside. And what comes first? We've got a function, 5 to the 0. Anything to the 0 power is 1. I also, not cheated, there's another technique. I call it the look ahead technique. I did 3 times 11 to get my 33. And that's fine because 3 times 11, the next thing it was going to do was going to combine with the negative 7 times whatever we get here. So it's not interfering. I'm still keeping first things first. So 3 times 11 is 33. Minus 7 just gets copied down. 5 to the 0 function gets simplified, brought down. Now I'm ready to work on this one. I've got multiplying first. So 33 minus 7. Now I can combine. And I get my answer 26. So calculate the complicated first is the principle behind order of operations. And so parentheses with stuff in it, like up here, that starts making things look complicated. Wow, we've got all this stuff. What am I going to do with it? Work inside first. Get all that complicated stuff in the box done, and then it becomes just a simple number to be multiplied or combined or whatever's going on out there as usual. And then we look at functions. And we calculate that, bring it down, and however they turn out. -2 parentheses. Oh, yeah, we've got stuff inside here, and now we've got a function inside. So notice now that we are inside, we start. Is there any inside to the inside? Nope. Is there a function inside the parentheses? Yes, there is. I do that first. Bring everything else down. So 4 squared comes down to 16. Everything else is copied. I'm still inside. I'm not ready to come outside. So I'm on my inside mud now. So 6 minus 3, nope, because 3 times 16 has to happen first. So bring it down, -2 parentheses 6, minus 48, minus 3 times 16, minus 48. I'm still inside, and now I use inside COLT. Combine 6 minus 48 is minus 42. I'm done inside. Now I can come outside. Any functions? No. Any multiplying? Yes. -2 times -42 gives me positive 84. Oh, nothing to combine. Fine, you can skip a step, but notice I never went out of order. I did everything I needed to in order. And we also see that we had inside order of operations to follow. Then we come out and we follow order of operations from the beginning all over again. One more introductory lesson on in. We're going to work with some boxes, and I'm now going to introduce the absolute value signs. On your keyboard, it's called the pipe, and they look like this with numbers. So yeah, when you draw them by hand and all that, make sure they don't end up looking like ones, and then your students start working with them as ones, and you wonder, what in the world are they thinking? Well, it was just a typo. Okay, let's look at this step right here. Is there anything inside boxes to be worked with? Yes, there are. So I'm working inside this box, and that comes down to the -4 here. I'm working inside this box, and 4 minus 9 comes down to -5. Now, one thing on absolute value, it makes the answer absolute value. It doesn't make each part of the problem absolute value. Wait until you get the final answer inside, and then you figure absolute value. So this should not become 4 plus 9. 4 minus 9 is -5. I still have my absolute value. Now, I still have some inside to work, but here again, I'm saving a step because this multiplying of the -1 times -4, which is the +4 down here, it combines with whatever I get over here. So that's fine. It's kind of like a separate problem. And within a problem, I'm following the order of operations on the left, and then I'm going to follow the order of operations on the right. And when they all get outside, I'm going to follow the order of operations together. If that gets too complicated in saving steps, fine, write out each step and do just one thing at each step and copy everything else down. That will work exactly the same way. Okay, so we've done this step. Now, -1 times -4 is +4, and we come down here. Now, the absolute value of -5 is just 5. The absolute value of a positive is a positive. The absolute value of a negative is a positive. It just turns every answer, your final answer, into a positive. And that's where I get this 5. This plus sign is that plus sign. Some books will write it out and they'll put 2 plus signs there, but you already know how to handle signs. A positive 5 is just a +5. Okay, and 4 plus 5, of course, is 9. Let's go over here now. Absolute values, let's work inside. -7 plus 1, and it comes down here to a -6. I couldn't do everything else. It's all tied up. Follow your order of operations, inside, outside. I'm not done inside, so I can't go outside. Now, 2 times the absolute value of -6. Well, what's the absolute value of -6? I bring it down here. There's my +6. And notice I change parentheses because now the function is calculated. I can use parentheses, or I could have used a dot here as well because it's 2 times absolute value. So it's 2 times absolute value. Any way you want. I could also use, of course, the little time sign. But as you see, I stop using the time signs as soon as possible with students because they get mixed up for X's. Okay, so now we are left with 2 times 6 times 3. Oh, well, that's all the same. I can do those all at once. 2 times 6 is 12, times 3, 36. I'm done.